Hey, what's going on? I'm Will from DevOps for Developers, and the National Security Administration recently released a guide on hardening Kubernetes that's surprisingly concise and actionable. So in this video, I'm going to go through some of the high topics or the key points in that document and show you how you can use them to apply to your own Kubernetes infrastructure and create better, more secure, harder Kubernetes environments. So now this document covers 5 main points. There's pod security, network separation, authentication and authorization, logs, and upgradeds. And so let's go through each one of those, starting with pod security. So when it comes to pod security, one of the first recommendations made by the NSA is that you need to run as non-root containers. So what that means is you're going to create users in your Docker images and run the application as that user, not as the default user 0 or root user. Now also, whenever possible, they recommend using immutable container file systems. And what that means is that the file system mounted in your Docker container can't be written to, it can only be read from. Now this isn't always possible, but there's good reason for doing this whenever you can. And it's so that if that container, or not if, but when that container is compromised, that the attacker can't upload their own code or executables to this container and use that to create an even bigger attack. The next recommendation is to build secure images. And I mean, it's kind of a vague term, right? But there's some steps that you can take to do this. One of those is if you use a tool like Snyk or Snyk, however you actually say that, they will scan your Docker code or your Docker images looking for known vulnerabilities. The other key part of this, though, is you got to be careful with where you get your Docker images from. It's really easy in a Docker file to type from and then type in an image name and use that as your base image. But what you got to understand when you're doing that is that whatever is in that Docker image you're using, you're running on your system. That means the security vulnerabilities that are baked into that image, the malicious code that comes with that image, the exploits that are baked in there, all of that kind of stuff is in there when you use that as your base image. So you got to selectively choose who you get your base images from. One of the things you can do in Kubernetes is enforce some of these constraints through the use of policies in your Kubernetes environment, and we'll dig into that a little bit in the next section. So our next section that we're going to talk about is authorization and authentication. Authentication is who the hell are you? Authorization is why are you here? So my name's Will, this is a stick up, open the cash register and put your hands on the counter where I can see them. Authentication and authorization, right? Okay, probably not the greatest example in the world, but I bet you get what I'm talking about now. So Kubernetes leaves it up to you to implement authorization, and the document, which I'll link down below, has a lot of has links over to the Kubernetes documentation to talk to you about the different authentication methods that you can implement and how to implement them. Now, authorization is commonly done with RBAC or role-based access controls, and there's kind of 2 different flavors here. There are roles and cluster roles. The difference between those 2 being that the permissions in a role can be restricted to a specific namespace, and cluster role permissions apply across the entire cluster, right? Now that's only half of the equation though, because you define the policies in the role or the cluster role, but then you actually bind them to a user or service account through a role binding or a cluster role binding. And so you got to have both of those working with your authentication mechanism in order to really lock that down. So the next section in the doc is logs, which at first glance you may be wondering why that's included in a hardening document. But the reason for it is it's necessary for audits and reconstruction of events. And I'll explain why in just a minute, but for right now, I want to tell you that the event logs are not enough. You need the event logs, plus you need the host operating system logs, plus you need application-specific logs, and if you're running in a cloud environment, you need the cloud logs as well. Now, the reason you need all of those is to be able to recreate scenarios and events after the fact, because Let's say you've got a worker node that spikes its CPU, has a large amount of network traffic going in and out of it. And so you isolate that, and then you need to go reconstruct what happened. So the only thing you have access to at that point are the logs. So if you only had the Kubernetes event logs, that doesn't really tell you a whole lot. But if you had the Kubernetes event logs telling you that this was a situation occurring, and then you combine that with the host logs to show that there was a huge spike in CPU utilization, followed by some increased network traffic, and you trace that and match that up with your application logs to show that there was a huge payload sent to your public-facing API server that's running on that node, you can piece that together to figure out that maybe you were sitting in the middle of a DDoS or a denial of service attack. But without all those logs from the different layers of your infrastructure, you can't really piece that together. The other key part of this is you have to get those logs out off of that node. So using remote logging or remote log storage location is going to be helpful to you for two reasons. One, if you lose that node or that piece of infrastructure completely, you lose the logs along with it if they're not stored somewhere remotely. And also, in the event of an attack, if you have an experienced attacker at all working against you, they're going to come in, they're going to attack your system, set it up to run the way they want it, and then they're going to go and delete all traces of being there out of the logs before they leave and go on to the next thing. And so using remote log storage can help minimize that from happening. So the last point that they make in this document from the NSA is talking about upgrades, and I'm really glad to see that they put this in here. And they simply point out that by upgrading and maintaining your Kubernetes environment with the latest version, you're getting bug fixes as well as patches for security vulnerabilities that have been discovered. And I think everyone knows that, but a lot of us hesitate to do that. And in my experience, one of the biggest reasons that people hesitate to upgrade is because they don't know what's going to happen if they have to roll back. And the large part of that is because we end up with these handcrafted servers. So I can't apply this patch on here because if it goes wrong, I don't know how to get back out to a known stable state. And I've done a lot of one-off stuff to this environment, so I can't recreate it. So for that reason, that's why it's so important that you never issue any command directly on your Kubernetes server or any of your servers for that matter for configuration. You want to put your configuration in a repository file or some type of repository, push that up through a Git workflow, and then once that workflow has been approved, use some type of automated tool. Or you don't even have to have an automated tool, just have like a dedicated place where people go and deploy changes to servers from that location and get out of that habit, break that habit of typing commands directly on your server. And then when things do go wrong and you have to replace a server, you're like, fine, I don't care. And you go run the command that you and your team have been practicing running day in and day out since you implemented this procedure. And so there you go. See what I mean? I mean, that was really kind of straightforward. Coming from the NSA, I was surprised at how straightforward and actionable that document was. Again, I will link it down below because there's a huge appendix in this thing with links taking you out for examples on how to do everything that they're recommending in there. If you enjoyed that video, I'm going to link a playlist right over here and show you some other videos I've recorded on real-world DevOps, just different things that I do on a regular basis that are DevOps oriented, just so that you know what it's like working in DevOps. And thanks for watching. I'll see y'all in the next video.